Hello everybody, thank you very much for coming on and joining the Quick Start online event today. I'll be covering common use cases for the cloud, including website and mobile applications, backups and disaster recovery. My name is Thomas Vandergein and I work as an account manager helping customers within New South Wales. Today, for the next 40 minutes, I'll be taking you through a number of common use cases for cloud. AWS Quick Start is the first edition of a new online learning series that AWS will be delivering to accelerate your success on the AWS cloud. We have AWS experts on hand to answer any questions you may have during their presentation, so please feel free to post your questions at any time in the Q&A console of the platform. At the conclusion of this session, I'll run through the most frequently asked questions and point you to the most relevant resources, including tutorials and quick start guides associated with the topic. At AWS, we also continually aim to improve on how we are able to service our customers better. If we can ask for 2 minutes of your time at the very end to provide us with your feedback on this session, that would be most helpful. Agenda-wise, today I want to walk through 3 main touch points: trends in cloud computing, disaster recovery and backups, and scaling out to your first 10 million users. So let's get started. Trends. The first thing that we're seeing with the customers that we work with is that cloud computing is and of itself has become the new normal for computing, either to deploy new applications built for the cloud or to migrate existing applications to gain new efficiencies. Since our creation in 2006, AWS has grown to serve millions of active customers every month across 190 different countries. And we've developed into a $20 billion run rate business faster than any technology company in history. We've gotten here because we keep customer obsession and constant innovation behind everything we do. And this is going to be a common thread that you see throughout this webinar, because it's 2 principles that drive a lot of the work that we do here, and a big part of why customers end up choosing AWS. So keep in mind customer obsession and innovation as we move through this webinar. So we're seeing a huge shift in uptake in cloud adoption. And I want to talk about a number of examples of why customers are beginning to move not just to the cloud, but specifically to AWS. Companies are moving from CapEx to OpEx so that they can pay as they go only for what services that they're actually consuming. They lower their overall cost of ownership and leverage our pricing philosophies and economies of scale to reduce their costs. They no longer have to forecast and guess how much capacity they need, and they can innovate more, meaning that they can lower the cost of failure and experiment with new things. Lastly, AWS takes care of a lot of the undifferentiated heavy lifting so that you don't have to do it yourself. And that focuses more of your time on doing what you're good at and what your customers want you to do. Lastly, companies are leveraging a global platform to go global with just a few clicks of a button. Since AWS's inception in 2006, our customer base accelerated when the Sydney region was launched in 2012. Today, tens of thousands of customers across Australia and New Zealand use the AWS platform, from startups all the way to enterprise-scale organizations. So what are some of the common migration drivers? The first one is agility. Companies want their engineers to be able to accelerate more quickly through development cycles. This is a huge driver because companies in the market today are very concerned about speed and time to market. The second one is ways to consolidating their data centers so that their engineers have less infrastructure to manage and have to do less things that don't add value to their core business. Customers who are on a digital transformation journey also use the cloud to do this, as well as customers looking at regional expansion. So as you can see, there are quite a lot of common drivers that are making companies look to migrating to the cloud. So how do you get started? I want to walk through 2 areas today. The first being retiring a technical debt, and the second being a digital transformation. Retiring technical debt goes through ways of backing up and archiving your on-premise data into the cloud and the different disaster recovery strategies that customers may look into when leveraging AWS. Digital transformation goes through how to deliver your website or mobile application to your customer base, scaling from your first customer all the way up to your first 10 million customers and everything in between. So let's get started on retiring technical debt. Many of our customers are telling us that they are being squeezed by shrinking SLAs and that their businesses require applications that are running in their DCs. Every application is considered as mission critical, so there are new DR requirements or more stringent ones. Even if you have a lot of infrastructure on-premise, cloud is still the preferred strategy for DR because of the economics, flexibility, and agility from cloud infrastructure. Traditional DR generally consists with massive upfront investment in hardware and higher ongoing costs. Data growth also then increasing the hardware and operational costs. Management and infrastructure overhead for globally distributed businesses. Whereas DR within the cloud generally consists of no upfront hardware investments, only paying for right-sized compute and storage which are actually needed, and lowering IT management overhead, and lastly, having systems up in minutes rather than hours or days. So there are three main availability concepts to look at. First one being high availability, meaning to keep your applications running 24/7. Second is backup, or making sure your data is safe. And lastly, disaster recovery, or getting your applications and your data back after a major disaster. Today, I would like to touch on two of these points, backup and disaster recovery, with you today. So let's start with backup and recovery. This simple and low-cost DR approach backs up your data and applications from anywhere to the AWS cloud for using during recovery from a disaster. Unlike conventional backup methods, data is not backed up to tape. Amazon EC2 computing instances are only used as needed for testing. And with Amazon S3, storage costs are as low as 1.5 cents per gigabyte stored for infrequent access. This DR strategy is best suitable for lower priority use cases and for services that can sustain longer recovery times. So how does this look? You can see that there are a few options to write on-premise backups to store in AWS. But I just wanted to walk through the first one today, which is leveraging File Gateway. The File Gateway enables you to store and retrieve objects in Amazon S3 using industry-standard file protocols. Files are stored as objects in your S3 buckets, access to a network file system mount point, and ownership, permissions, and timestamps are durably stored in the S3 in the user metadata of the object associated with the file. Once objects are transferred to S3, they can be managed as a native S3 object, and bucket policies such as versioning, lifecycle management, and cross-region replication apply directly to objects stored in your bucket. Customers use the file interface to migrate file data into S3 for use by object-based workloads, as a cost-effective storage target for traditional backup applications, and as a tier in the cloud for on-premise file storage. Now, the next concept is disaster recovery. The first phase of disaster recovery is to identify the applications that you have to protect, and to define what protection looks like to that application. The business impact analysis is helpful to determine what DR is really worth to your business for that application, and to give you an idea of what cost targets you want to work with. Based on that, you should get your recovery time object, or RTO, and recovery point objective, or RPO. So let's spend some more time talking about these. Your recovery point objectives talk to your maximum amount of data loss accepted for an application to go down. So if we plot in our timeline to, let's say, the disaster occurs sometime here in the middle, your RPO will be at some point in time prior to the disaster. The point in time at which all the data up to that point will be recoverable in the event of a disaster. If a disaster strikes, we can expect to lose the data between our RPO and the time of our disaster. You'll find RTO happens after the disaster occurs, so the amount of time that you're willing to accept before the system comes back online. As you can see from the above diagram, there are a number of strategies that can be used in the event of a disaster. You'll have to keep in mind complexity versus time when looking at what strategy suits your case best. We'll dive into these a little deeper in the coming slides, but as you can see, the higher the complexity of your DR strategy, the higher the cost may be. However, on the flip side, it can lead to a much quicker and effective RPO and RTO. So now let's take some time looking into some of our DR strategies. So first we've got the pilot light. The term pilot light is often used to describe a DR scenario in which a minimal version of an environment is always running in the cloud. This scenario is similar to a backup and restore scenario. For example, with AWS, you can maintain a pilot light by configuring and running the most critical core elements of your system in AWS. When the time comes for recovery, you can rapidly provision a full-scale production environment around the critical core. Infrastructure elements for the pilot light itself typically include your database servers, which would replicate data to Amazon EC2 or Amazon RDS. And depending on the system, there might be other critical data outside of the database that needs to be replicated to AWS. This is the critical core of the system, or the pilot light, around which all the other infrastructure pieces in the AWS can quickly be provisioned to restore the complete system. To provision the remainder of the infrastructure to restore business-critical services, you would typically have some pre-configured server bundles as Amazon Machine Images, or AMIs, which are ready to be started up at the moment's notice. The following figure shows a preparation phase, in which you need to have all your regularly changing data replicated to the pilot light, the small core around which the full environment will be started in the recovery phase. Your less frequently updated data, such as operating systems and applications, can be periodically updated and stored within the AMI. Now, this is the recovery phase. To recover the remainder of the environment around the pilot light, you can start your systems from the AMIs within minutes on the appropriate instance types. For your dynamic data servers, you can resize them to handle production volumes as needed or add capacity accordingly. Horizontal scaling often is the most cost-effective, scalable approach to add capacity to a system. For example, you can add more web services at peak times. However, you can also choose larger Amazon EC2 instance types and thus scale vertically for applications such as a relational database. From a networking perspective, any required DNS updates can be done in parallel. After recovery, you should always ensure that redundancy is restored as quickly as possible. A failure of your DI environment shortly after your production environment fails is unlikely, but you should be aware of the risk. Continue to take regular backups of your system and consider additional redundancy at the data layer. The following figure shows the recovery phase of the pilot scenario. Next, we have the warm standby approach. The term warm standby is used to describe a DR scenario in which a scaled down version of a fully functional environment is always running in the cloud. A warm standby solution extends the pilot light elements and preparations. It further decreases the recovery time because some services are always running. By identifying your business critical systems, you can fully duplicate these systems on AWS and have them always on. These servers can be running on a minimum sized fleet of Amazon EC2 instances on the smallest size as possible. This solution is not scaled to take a full production workload, but it is fully functional. So it can be used for non-production work, such as testing, quality assurance, and internal use. In the event of a disaster, the system is scaled up quickly to handle production load. In AWS, this can be done by adding more instances to the load balancer and by resizing the small capacity servers to run on larger Amazon EC2 instance types. As stated in the preceding section, horizontal scaling is definitely preferred over vertical scaling. The following figure shows a preparation phase for a warm standby solution, in which an on-site solution and AWS solution run side by side. Now, this is the recovery phase. In the case of a failure of the production systems, the standby environment will be scaled up for production load, and DNS records will be changed to route all traffic to AWS. And lastly, you have your hot site, which is a multi-site solution which runs in AWS as well as your existing on-site infrastructure and in an active-active configuration. You can use a DNS service that supports weighted routing, such as Amazon Route 53, to route production traffic to different sites that deliver the same application or service. A proportion of traffic will go to your infrastructure in AWS, and the remainder will go on your on-site infrastructure. In an on-site disaster recovery situation, you can adjust the DNS weighting and send all traffic to the AWS service. The capacity of the AWS service can be rapidly increased to handle the full production load. You can use Amazon EC2 auto scaling to automate this process for you. The following figure shows how you can use the weighted routing policy of the Amazon Route 53 DNS to route a portion of your traffic to the AWS site. The application on AWS might access data sources in the on-site production systems, and data is replicated or mirrored to the AWS infrastructure. And now onto the recovery phase. The following figure shows a change in traffic routing in the event of an on-site disaster. Traffic is cut over to the AWS infrastructure by updating DNS, and all traffic and supporting data queries are supported by the AWS infrastructure. So that finishes the first use case for cloud around backup and disaster recovery. Now I want to take you through our second use case for cloud, being digital transformation. No matter how many users you have, scalability is going to be an issue, but it's a great value proposition of the cloud. I'm going to walk you through how to start from your first user and scale your environment out to support thousands and up to millions of users. So let's start from the beginning, day one. This is you, the user, so looking at a single user approach. Potentially, this is how it can all start. However, as more users start to come on board, you may start to hear something like, we're going to need a bigger box, which is possible. As you can see, there are many different types of instances that you can choose between. Instances with high memory, high CPU, or high I/O. And it's easy to change between these instance sizes. But one thing you should always keep in mind is that you will eventually hit an endpoint. And this will always be a problem when you architect with just a single instance on your architecture. When you have just a single instance, this leads to no failure and no redundancy, leaving all your eggs in one basket. So, one of the first things we suggest when scaling over one user is to separate your database tier from your web tier. The amount of load on the database and web tier may be different, so we want to be able to manage these separately. When it comes to choosing a database, you do have a few options. You can put your database of choice on an EC2 instance, but the catch with this is you'll need to manage it yourself, meaning you'll need to do the patching and the backups. This can take valuable time off your hands or off the hands of your team. So another option is to go manage databases, like Amazon RDS or Relational Database Service, and even DynamoDB. So what happens when you reach your first 100 users? If we're going for hundreds of users, I would recommend starting to leverage services like our Relational Database Service. And you'll start to see why as we go a little bit deeper. So now we're getting to thousands of users. You can see that we now start leveraging multiple availability zones and now starting to scale horizontally. You'll scale horizontally to support the number of users you are seeing and to support the load that is happening on these instances. We are also using a feature of the Relational Database Service now, which is creating a slave database in a separate availability zone, which is replicating and keeping the data up to date for us, so that if we have a failure in our master database, our Relational Database Service will automatically fail over into the slave for us. You can see we are also able to load balance between the different available instances using a load balancer, which is enabling our horizontal scaling. Elastic load balancing automatically distributes incoming application traffic across multiple targets, such as an Amazon EC2 instance and IP addresses. It can handle the varying load of your application traffic in a single AZ or across multiple availability zones. The ELB is highly available, can detect unhealthy targets and stop sending traffic to them, and then spread the load across the remaining healthy targets through health checks, and also offers monitoring and logging. The application load balancer is one of your choices within your ELB. This option adds content-based routing, container-based app support, and WebSocket support. So this gives us the ability to either scale up horizontally or by adding new instances, or by scaling vertically by changing the type of instances. Now with this basic architecture, this will then give us the ability to start handling tens to hundreds of thousands of users. And the architecture would start looking at something like this. We scale out increasingly across our availability zones. We will also use another feature as part of our Relational Database Service. Some of the engines we have available on our Relational Database Service allow for read replicas. Read replicas allow you to offload read requests from your web servers from your master database. Again, this is spreading the load across multiple components of your systems. Spreading of our load will become a much more common theme going forward. Now, we can spread the load even further again. We can take the static content from our web instances and serve this from Amazon S3. We can do this and then put Amazon CloudFront in front of this and cache our content closer to where the users are, reducing the latency that the users experience. S3, or Simple Storage Service, is one of the services you see on almost every architecture. It is extremely durable, designed for 11 nines of durability, meaning if you had 10,000 objects, you might lose one after about 10 million years. It's also infinitely scalable in terms of both storage volume and request volumes. The other service I mentioned is CloudFront, which is our content delivery network service. This caches content on the edge location, so it's closer to where your users request that content from. You can also use this to speed up dynamic content as it will optimize the route to your dynamic content. Going back to the theme of spreading load, using a content delivery network can reduce load time and server time, because every request that hits CloudFront doesn't hit S3 or the web server. So now we can start shifting the load around even further. We can cache our requests to our database using Amazon ElastiCache, which is our managed Memcached or Redis cluster. It will scale up to as many nodes as you need and will heal nodes that fail and replace them. And it will give you a single digital millisecond speed. Another way we can shift the load around is moving our session data to a NoSQL database. And we can use Amazon DynamoDB, which is our managed service for this. And now we have an architecture that can support upwards of 500,000 users. We scale out using our load balancer and store static content on S3. We're caching and have our session stores on DynamoDB. We're using read replicas and have our multi-AZ standby feature of our relational database. And now we have auto-scaling across our availability zones. Now, what about scaling up to upwards of 1 million users? This will require bits of everything we have gone over so far. Having a multi-AZ setup, load balancing between tiers, setting up auto-scaling, serving content smartly through services like S3 and CloudFront, but also introducing some new services like event-driven compute through AWS Lambda. You can see here a few new components come in to help scale out to our 1 million user count. For example, the introduction of worker instances, which are taking work from a queue loosely coupled from our system, doing the work for us. We're using Lambda to take events from DynamoDB and S3, and we are monitoring the whole thing with CloudWatch. So for a quick review, we want to multi-AZ our infrastructure. You want to start making use of self-scaling services like Elastic Load Balancing and Amazon S3. And we want to start building a redundancy at every level and caching data both inside and outside of our infrastructure. You want to make sure you have good metrics and monitoring. You want to start splitting tiers into individual services and use auto-scaling when you're ready for it. And don't reinvent the wheel. With all this will enable us to scale up and go beyond 10 million users. When it comes to 10 million users, there is added complexity. And so this is where you start looking into more areas around fine-tuning of your application. You can start introducing serverless functionality and features. And you've also got the opportunity from going from a multi-AZ to a multi-region approach. So, what are the next steps from here? The AWS ecosystem ensures you're not alone in making this journey. To get started, you have access to loads of resources, including quick starts, getting started tutorials, architectures, and service documentation. You can start leveraging the AWS platform for free within our AWS free tier to get a feeling of how the AWS platform works. You also have an AWS support team, an extensive AWS partner network, who are there to help guide you through your journey, as well as dedicated local AWS account teams, including account managers like myself and your solution architects. So I'd like to thank you all very much for taking the time to jump online and watching this session. I hope that the content we've gone through today has been helpful to you and hopefully has given you an idea around some of the common use cases for cloud. Please, it would be amazing if you could take the next couple of minutes to complete our poll survey to ensure we can continually improve and meet our needs. Thank you very much for your time.